We're going to use the ratio test to determine whether the series converges or diverges. So with the ratio test, we find the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And then if L is greater than 1, it diverges. It diverges. If L is equal to 1, it tells you nothing, and you have to do some other test. If L is less than 1, then it absolutely converges, which implies that it also converges. It converges normally. So now that's what we're going to do. We're going to find out what L is when we apply this. So we're going to get L equals the limit as n approaches infinity of a sub n plus 1, which would be negative 1 to the n over 3 with times 3 to the n plus 1 over 2 to the n plus 1 times n plus 1 cubed. In the numerator, in the denominator, we get the normal version. Now we can cancel out these because we're absolute valuing it. So the only thing that this could ever be is negative 1 or 1, but the negative 1 is ignorable. So now we could just have 1, since we have absolute valued all the instances of negative 1. Now we could switch this into a reciprocal so that we can see it better. This is going to be 3 to the power of n plus 1 over 2 to the power of n plus 1 times n plus 1 cubed, and we're multiplying this by 2 to the n times n cubed over 3 to the n. And what I would do is I would group together what looks more similar. So this looks similar to this one, and this looks similar to this. So I would group them together. You could always, switch them because we're multiplying after all. So we could do that. 3 to the power of n plus 1 over 3 to the power of n. And then on the other side, we have 2 to the power of n times n cubed over 2 to the power of n plus 1 times n plus 1 cubed. Here we're left with 3, because 3 to the power of n cancels with a 3 to the power of n, but you still have a 3 to the power of 1. So you would still have 3. Here, 2 to the power of n would cancel with 2 to the power of n, but you would still have 2 in the denominator. You would still have 2 in the denominator because you had 2 to the power of n plus 1. So the power of 1 still remains. Now we could factor out the 3 halves and leave that by itself. So limit as n approaches infinity of 3 halves times n cubed over n plus 1 cubed. So since both the numerator and the denominator are being cubed, we could bring out the cubed. So this would be the limit as the n approaches infinity of 3 halves, and we have n over n plus 1, and that's all cubed. Now we can more easily take the limit by dividing everything in there by n. So if we divide this by n, that becomes 1, this becomes 1, and this becomes 0. Because we're going to plug infinity into the denominator. So that would give us 1, once we take the limit as n approaches infinity. And 1 cubed is just 1, so we would get 3 halves. 3 halves is larger than 1. So this diverges by the ratio test.